If you're having problems regulating a watch that uses the Etachron regulation system, more than likely it's because you're not adjusting it before you start trying to regulate the rate. In today's video, not only am I going to show you how to remove and install a new balance wheel and hairspring, but I'm going to take you step by step through the entire process of adjustment that sets up the regulator to be able to adjust the rate from multiple positions. This is part of a series of videos on watch regulation and adjustment that I'm doing. So if you're new to watchmaking, you may want to follow along. And we're going to do it starting right now. So what's different about the Etachron regulator? Well, around 1976, ETA introduced this new two-part regulator system that replaced the adjustable regulator pins that have pretty much been used forever. This was a big advancement for regulators, and they did it by only changing two small things. The first change was to the stud block. Instead of holding the hairspring to the stud block with a tapered pin, the hairspring was now permanently epoxied to the block. Then, instead of the stud block being held in a fixed position, the stud block is held under tension in a fork slot, which allows the hairspring's position to be easily adjusted. The second change was to the regulator pins themselves. In the Etachron system, the regulator block has two fixed pins, which keep the pins at a 90-degree angle to the hairspring. Because this new regulator block is also held in place under tension in a retaining fork, it allows the entire block to be rotated, closing the gap between the hairspring and the regulator pins, without having to actually bend the pins themselves. Now, like always, in order to be able to regulate any movement, it needs to first be properly serviced and lubricated. The movement should be free of all magnetism. The gear train must be running freely. All end and side shakes should be normal. The hairspring should be flat and centered on the collet. The movement should be in beat. The escapement needs to be operating correctly. And you should have a consistent amplitude of at least 270 degrees in the horizontal positions. So let's start by removing the balance wheel. Now, removing the hairspring and balance wheel is pretty straightforward. There's just a couple small things that you need to remember. First of all, you're going to always want to do it with the balance cock mounted to the bridge. And the second thing that you need to do is we need to put the regulator pins in the correct position to remove the hairspring. So as you're looking at the hairspring regulator, you can see that it's tilted slightly towards the hairspring stud. What we want to do is straighten it out so that the gap is parallel to the hairspring once we flip it over. Now, they have tools to do these adjustments, but in this particular case, you can just use your tweezers. We're going to slowly turn it until the regulator pins are at their widest point. So when you're looking at the top, you want this running straight up and down. Next, we need to remove the hairspring stud from the fork that holds it. Now, they have tools to remove this, and I'd actually bought one, but the first time I used it, it broke. So I've used my go-to method ever since, not looking for any tools to help me out here, because you really don't need one for this. These two forks are under tension. So what we need to do is get something in this area that we can just push the stud out. For this, I find my bronze tweezers work the best. So what we're going to do is just put one tine into the gap, and then we're just going to slowly twist it until the hairspring stud pops out. Now, and try to do this without putting any pressure down on top of the stud arm. Just want to give it a nice gentle twist, and the hairspring stud is free. And now we'll just go ahead and remove the balance cock. So I like to start by just loosening the balance cock from the main plate. And then we're going to pick up the balance wheel and the cock together, because remember, we don't have the spring attached to it. And we can just pick it up and flip it over on its back. Now, with the balance cock removed from the watch, the next thing we need to do is get the hairspring out from between this little slit between the two regulator pins. So again, I like to use bronze tweezers. We're just going to grab the hairspring and gently lift it off. Now, when we look at the two regulator pins, you'll see that the opening at the bottom is just wide enough to get the hairspring out. So if you are struggling a little bit to get it out, first make sure that you're pulling it straight up, because in order to separate these, to make it wider, you'll need to use a razor blade to spread it open a little bit, which means you'll also need to close it back as well. And it would really be best if you didn't have to fool around with that at all. So be patient, make sure that you're pulling straight up on the hairspring gently, and it should slide right through that groove at the bottom of the regulator pins. Now, when you're replacing a balance complete, which, as you probably already know, is the balance wheel and hairspring, this is done as a set. If you have a movement with the Etachron Regulator and you have a damaged hairspring, you're going to need to replace both the hairspring and the balance wheel. The hairspring and balance wheel are poised together at the factory as a set, and this is what you need when you go to replace these. You want a set that have been vibrated together. When you look at a balance wheel, after it's been poised with the hairspring, you'll notice that there's a slight groove cut on the underside of the balance wheel. Well, during the poising operation, it was determined by the factory that this area of the balance wheel was heavier than the rest of the areas around the balance wheel. So this is where a little bit of material was cut away from the underside of the balance wheel to make the balance wheel balanced. Now, the amount of material that's cut away from this balance wheel, its location on the balance wheel, is all factored on this particular hairspring. Now, to reinstall the new balance wheel, we're just going to set it roughly in place where it's going to be. We're going to hold down the bridge and just drop the hairspring through the groove. Now we're going to go in and we're going to pick up both the balance wheel and the cock as one piece, flip it over, and then we're going to put it in position on the movement, roughly in the place where everything is going to ultimately be installed. Now at this point, I don't care about the impulse jewel being in the fork slot. All I really want to do before I put the screw in is I want to make sure that my pivots are in the pivot holes. So when I put my screw on, I don't bend or break the pivots. And to do this, I'm just going to lightly hold down the balance cock, and I'm just going to see how the balance wheel acts. And it certainly looks like the pivots are in their pivot holes. So now I'm just going to get my screw started. As soon as I feel the first bit of resistance, as I tighten the screw down, I'm going to stop. I'm going to check it again. And now I'm just going to move the hairspring stud to the location on the fork where it's going to snap in. It looks like we're still in the pivot holes. Just tighten it down a little bit more. Clearly we can see that the impulse jewel is not in the fork slot. But now with the hairspring stud in position, I'm just going to take the back side of my bronze tweezers and I'm going to lay them on the side of the hairspring stud at a 90-degree angle, holding the tweezers in my right hand, and with my left index finger, I'm just going to slowly apply pressure to the stud until it snaps in position. Now, with the hairspring stud secured in place, now we can remove the balance cock and reinstall it properly. And that's how you install a new balance complete on a movement with the Etachron system. All right, so the first step in adjusting the Etachron system is we want to put the watch in beat. So I've given the movement a full wind. And now I'm just going to make some small adjustments until we can get the beat error to 0. Now in watch repair, you shouldn't really obsess too much over beat error. As I've talked about before, beat errors under 1.0 milliseconds do not affect the timing of the watch. So if you're working on an older vintage watch where you have to turn the collet to adjust the beat error, you know, if you can get it down to 0.4 or 0.5 milliseconds, I would be happy with that. Sometimes you get lucky and you can get it to 0 or 0.1 milliseconds. Just get it as close to 0 and as far away as 9 as you can get. Now in modern movements like this, adjusting beat error is pretty simple because you don't have to take the balance out to change it or adjust it. And since we're talking about beat error, just be aware that there's many other things that could cause a watch to be out of beat. For example, you could have a sloppy pallet arbor. You could have something like a loose roller jewel or a loose pallet stone or a loose cap jewel. All those things will cause beat errors, as well as loose regulator pins and banking pins. They can also cause a beat error. One of the most common causes of beat error in older vintage watches is the hairspring collet is just loose. And maybe one of the harder things to detect is the guard pin is rubbing on the safety roller. Now that the watch is in beat, we're going to go ahead and let down the power to the mainspring until our balance wheel stops. Now the next thing we want to make sure is that our micro adjustment screw is pointing straight up to the middle. And if you haven't done it already, you want to make sure that the regulator pins are in the fully open position, which you can tell by looking at the top of the regulator stud. So step one in making these adjustments is we want to look at the current spacing of the coils of the mainspring. So you'll just have to peer in between things so that you can see. And what we're looking for really is we're looking for any bunching. And that will basically tell us that the hairspring is not concentric. So there's one side, and then we can see the other side. It looks pretty good. So the first thing that we need to do now is we want to center the hairspring in between the regulator pins. Now looking at the hairspring in between the regulator pins, I think it's obvious when you're looking at it at this angle to see that it's not centered in between the regulator pins. It's not tight up against the inside pin, but we need to adjust it so that it starts off in the middle. If you're not sure why that's important, the video that I did previous to this one was about the relationship of the regulator pins with the hairspring, and I'll leave a link in the description for that video. Now, to make this adjustment, there is a special tool that you're going to want to have. Now, you can turn the regulator block with a pair of tweezers, but this is an incredibly fine movement, and it's going to be very hard to do it effectively with a pair of tweezers, especially depending on the angle which you're trying to see the actual hairspring. Now, the way you adjust the hairspring to the middle of the regulator pins is by inserting this tool on top of the hairspring stud. There, I think you should just be able to see the tool on the hairspring stud. And then we're going to very slowly and carefully turn the tool until the hairspring is in line with the center of the regulator pins. So now that we have the hairspring centered in the regulator block, the next thing we want to check is the regulator curve here. So what we want to do is we want to move the regulator arm along the regulator curve from one end to the other. And what our goal is that the hairspring doesn't move. If the hairspring does move, that means that this curve is out of shape and will need to be adjusted. So in order to check this, we're going to move the regulator arm from one end of the regulator curve to the other. And what we're going to do is we're going to focus on the coils right here. And what we're going to look for is to see if the spacing between those coils changes. Well, clearly we can see that the coils got smaller. So that means this regulator curve needs an adjustment. So let's go ahead and do that. Now, to find the problem on the hairspring, I've went ahead and taken the balance wheel back out of the movement. And when we look at the spacings on the coil, we can clearly see in the lower half right here where the coils are closer together than any other place on the hairspring. Now, the first thing I would probably do is make sure that it's not magnetized. This is a pair of carbon steel tweezers, and you can clearly see that it is not magnetized. Otherwise, the hairspring would be sticking to the tweezers. So here lies at least one problem with the hairspring that we need to correct. Now, in theory, hairspring corrections are pretty straightforward, as there's really only two rules that you need to be aware of. When the spacing of the coils is incorrect, the correction point is 90 degrees away from the problem area. So basically what you do is you look for the area on the hairspring where the coils are either too close together or too far away from each other. And the correction area is going to be 90 degrees from that point. Now, looking at this hairspring, I can see that here's where the coils are closer together than they should be. So the area of correction is going to be 90 degrees away from this point. So about right here is where we're going to grab the hairspring with our tweezers, and we're going to needle it out, or we're going to bend it out a little bit to correct this gap right here. Now, when we're doing needling work, The shape of your tweezers makes a lot of difference in how easy it is to actually grab the hairspring itself. And there's a couple different styles, it doesn't really matter. Straight tweezers like this, I think you'll find that they're a little bit awkward, but they will work. I prefer using a curved pair of tweezers. Here's one style. This one is really specifically for holding hairsprings, but some people prefer just a curved pair of tweezers. Either one works. Now, beside the tweezers, you also need a needling tool. Now, you can find needling tools for hairsprings on websites like eBay, and I think you can even buy new ones, but this is one that I made myself. It is essentially just a sewing needle that I heated up the end so that I could put a bend in it and epoxied it into a piece of pegwood. And then I just shaped the end of the needle on a Arkansas stone to thin it out, and then just polished it with palladium, just a high gloss polish on a hard felt wheel. So that's really all there is to that. So again, looking at our hairspring, here's the point where the coils are too close together, and we're just going to go back 90 degrees, grab our hairspring, and we're just going to lightly bend it up. What's important here when you're making these type of corrections is that you want to make very small corrections at a time. Don't try to correct the bend in one shot. Make small little corrections until you get it where you need it. Now, the next thing that I can see is that the regulator curve, the width here, gets narrow when it gets up close to the hairspring stud. So I'm going to go 90 degrees from this area. I'm going to grab the hairspring and just give it a slight needle, slight little rub. See if we can open that up just a little bit. And ever so slight, we're just rubbing the needle lightly across the hairspring, ever so slightly. Now we'll go ahead and install the hairspring back into the movement, and we'll check our work. All right, so we have the balance wheel reinstalled back into the movement. I've moved the regulator to the bottom of the regulator curve, and now we need to center the hairspring again. Now, just as a general rule, the gap that we're looking for between the hairspring and the regulator pins is about the thickness of the hairspring itself. So as I'm looking at the hairspring between the regulator pins, what I'm looking for is to just try to get the gap even on both sides, which is about the width of the hairspring. So now that looks good to me. So what we're going to do now is we're going to move the regulator arm up the regulator curve. And what we're looking for is to see if the width of the coils right here change as we move up the regulator curve. So here we go. Now that we have the regulator curve centered on the pins along the length of the regulator curve, now we're going to bring the regulator back towards the middle. And now what we're going to do is we're going to close the gap by turning the key on the top of the regulator pins to close the gap between the hairspring and the regulator pins. Now, the one thing you want to do when you make this adjustment is that you turn it towards the hairspring stud. So we're going to close the gap. We're going to turn this so this corner moves this way. We don't want this corner moving that way. Now, if the hairspring stud was on this side, we would turn it towards the hairspring stud over here. But since it's on the right side right here, we're going to turn it clockwise. So let's do that next. Now the key here is we do not want the regulator pins to bind on the hairspring. So this is going to be a micro adjustment of the regulator pins themselves. Now, I want you to think about what we just did. We started off by adjusting the hairspring so that it was centered in between the regulator pins. Then we checked the travel of the regulator pins up along the regulator curve, which revealed that the curve was not concentric, and that the pins were now pulling on the hairspring, causing the coils on one side to bunch up. We then made another series of adjustments to the coils of the hairspring to correct the errors of the spacing between the coils. Now, once that adjustment was made, we reinstalled the balance, and then we rechecked the travel of the regulator arm along the curve, verifying that no matter where the regulator pins are along that curve, that the hairspring will still be centered, and therefore it's going to act the same no matter whether you're in a horizontal or vertical position. Then we made one final adjustment to close the gap between the hairspring and the pins. This entire process is what is known as adjusting, which will always be done prior to regulating the movement for rate, no matter whether it's a watch with the Etachron system or if it's a 100-year-old pocket watch. The process is basically going to be the same. Now, the regulation tool that I used is pretty much one of those tools that's really a must-have if you're going to be working on Etachron systems. But if you have files available and you can cut a slot 0.6 of a millimeter, then you are better off just making the tool yourself. I made this one in about 30 minutes using a piece of 2.5 millimeter brass. I just installed the rod into my screwdriver sharpening jig to get this taper. And then to cut the slot, I just used a screw slotting file, and I sized the opening to be just a little bit larger than the regulator and hairspring keys. I'll leave links to all the tools I used in the description below in case you want to make one yourself. As you can see, not only can you turn the keys for the pins and the stud, but unlike the Bergeron tool, you can actually see how much the key is moving. And that brings me to my second bonus tip of the day. The Bergeron tool works great except for one thing. It's hard to gauge how much you're turning it. To solve this problem, you can attach an hour hand to the shaft of the tool, and now when you turn it, you can see exactly how much it's moving using this hand as a visual gauge. Now the shaft on the tool is 1.5 millimeters, so pocket watch hands are going to work better, but you could also use standard 1.2 millimeter hands and just open it up with a smoothing broach. Now, for any of you who are patrons, I uploaded the first part of a 2-part series on the 6-step escapement inspection. In this Master Series video, I'm going into great detail on how the escapement works and how you go about troubleshooting and correcting problems in the escapement. So if you have any interest in this type of thing, check out my Patreon page whenever you get a chance. Thanks for watching, and because there's so much more to learn, I'll see you in the next video.